Now in this part we will see an overview of the, so to say, information modeling. We somehow have information we want to collect, and therefore we need to do the information modeling. Now, first, a brief introduction to the topic. If we talk about information modeling, then we look at the information we would like to persist in a database. And this information modeling is one of the first important steps in designing something which will persist our amount of data for later. And so it is a very crucial point in the overall project, and it's a core discipline for database development. And what depends on information modeling is the later quality of your database. So if you make a good information modeling with consistent data, without redundancy, then this will lead to a good database quality. If not, then this will lead to a suboptimal quality of your database. You might have redundancy, you might have inconsistencies, and so on. And for doing this information modeling, we have tons of methods available. We will concentrate here on the entity relationship model. It is a common graphically supported language where you can model the dependencies of the information, of the parts of the information, and see them in the aggregation of the overall picture. We will mainly look at the graphical part of the model. You can also express it as text, but that's not so important here for us. And there are, of course, other methodologies available. For example, UML, the Unified Modeling Language, is one other popular modeling language. It's more popular for software development, and the entity relationship model is more focused on the information modeling in the database context. We could also use UML, but here we will focus on the ERM. So what we do now is we perform the so-called database design, and this is just the structuring of the information. We identify the main parts of our area of information such that we can identify the most important entities, their relations to each other, and maybe their properties, their attributes, to tell something more in detail about the entities. Now, how is the process of the database development? As I said before, information modeling is one important part, but it's not the only activity we have to do for database design. We start usually with requirements analysis, requirements engineering, and that means that we first look to the user and we ask the user what he or she wants to do with the database, how he or she wants to use the data, what requests the user would like to do, so that we get a clear picture of what the user actually wants to do with the information and how is the information structured. Then we do the conceptual design, and that's the part where we apply the information modeling. Conceptual design means that we structure the data, we model the information with the ERM. After the modeling in the entity relationship model, we come to the logical design. That means that we have to choose a particular database system, a particular database model. And here we concentrate on the relational database model. It means that we think in tables. We will see later that we map our information to tables and to relations between these tables. And actually we can start with the conceptual design, and then we just apply a set of rules to transform the conceptual design into a logical schema. And there's basically no creativity required. You just apply the rules to come to the structure of tables which maps to your conceptual design done before. And there are also some methodologies to improve this relational model. Then you, for instance, can do the normalization. That means some cleaning up of the schema to avoid redundancies and to resolve some inconsistencies. After the logical design is done, we have a set of tables we would like to implement into the database, and this implementation into the database comes with the data definition. There we use the database language, and the database language here in our focus will be the SQL. SQL as a structured query language, and that means that we have means to talk to the database to create the tables like we created them in the logical schema, and to prepare our database such that it can take the information later on in this process. Then the database manager would do some physical design that's more into the details of the database, and later on during the runtime of the project, during the runtime of the persistency, the maintenance would follow. So now let's first quickly look into the requirements analysis. Requirements come from the user, from the data user of the database, of the information. And that means that the user has some information in mind which he wants to persist in the database management system. And for the database developer, for the information modeler, it's now important to find out what kind of objects are there in the space of the information of the user, what kind of attributes might describe these objects in detail, and what relations exist between the objects, and maybe also which attributes have these relations. And you can collect these information about the requirements in tables, for example, like you see here in this table on the right side. You have some information about a kind of person. You want to somehow model a person, and what is important in your information model is the information about a person number. This seems to be kind of integer, and the length, let's say it's 8 digits long. And also about the person, the name should be modeled, the name should be persisted in the database, and for the name you reserve 30 characters. So this type is named string then. And you would do these analysis of the attributes, of the types for the attributes for all objects you would have in your information model. So you request the user, you as the information modeler request the user what kind of information he wants to save, and then he tells you, oh, I have a person with some attributes, with some properties, and maybe something else, some cars or houses or whatever. And you then have to identify if these cars, houses are objects on their own and what kind of attributes they would have. And then persons might have relations to cars, to houses, and then you also write up these relations as the requirements for your requirements analysis. Second part is the requirements for processing. It's not only the static data model you need to analyze regarding the requirements, you also need to analyze the processing which might be done with the data. Here in this part of the information modeling we will not focus on the processing, but might be important to know which information you request, which updates come into the database, and which reports you might want to produce for your data. What is more important on the technical side is about the qualities, maybe the priorities of the processing. So how many data do you have? What data volumes do you expect in your application? Are there hundreds of persons? Are there thousands of persons? Or are there millions of persons, for example? And also the frequencies of the processing. How often do you execute a certain function, for example? And last but not least, not all users of the database should see the information which is persisted in the database. Some person should have access rights to all information. Some other person should be able to see only a part of the information, only a small view onto the information which is persisted. And that's why you have to think about access rights for different persons or different groups of persons. This leads us then to our conceptual design. So we take the requirements, we take the information we got from the later user, and we try to design our model first. So this is a kind of abstract methodology, abstract because it's not concrete in the tables, not concrete in the database yet. It's first a conceptual design such that you get an idea about the information you would save later on in the database. And the methodology we choose here is the entity relationship diagram. And in the lower part of the slide, you see an example of this entity relationship diagram. Obviously, there are information about an employee saved in the database. The employee might have an employee number, an employee name, and maybe some other attributes as well. And there's also a department the employee works in, and the department also has a department number and a department name. So this is a small view into the methodology, and we will look into detail in the following slides.